Good evening, students. In last class, I discussed one component system. The application of one component system is one is a water system, another is a sulfur system. One is water and second one is a sulfur system. In yesterday's class, I discussed this water system, that is one component system. In today's class, I discuss about the sulfur system. One component, the application of one component system. Example, sulfur system. Sulfur system. In studying the component, one component system, it is a water system as well as a sulfur system. The PT graph is very important. That is, the phase diagram is very important. I draw a phase diagram for sulfur system. This is the x and this is the y-axis. Here I taken on x-axis temperature, and y-axis pressure. Here I take a line. This is A. This point is A, and this is B, and C, and this is D, E, and this point is G. Here, and here I take S, and this is point comes to here, and this is a F, and this is a F. I indicate this point is F. This point comes to here, and this point comes to here. This is a 95.6 degrees Celsius. This is a 114 degrees Celsius. This is a 120 degrees Celsius. Here, this point is 150 degrees Celsius, 151 degrees Celsius, and 1290. This is the atmospheric pressure. Okay, here this curve, I name this curve sublimation, and here B curve is the sublimation curve, and here BC is a sublimation curve. This BC is a sublimation curve. Right here, sublimation curve. Okay. Here, SM, SV, here SR, SV. And this is vapor pressure curve. This is vapor pressure curve. And this is transition curve. Transition curve. And this is fusion curve. Fusion curve. And this is also fusion. Here, this is a PT graph for a. This is SR solid. This is SM solid. And this one is SL. Here I written SL and here SV. SR, SL, SM, SV. Okay, this is the phase diagram. This curve indicated here. I write SR, SV. And this SM, SV. And this is SL, SV. And this SR, SV. So here SR, SV. And this is SR, SV. Okay, you understood here. According to this diagram, it has one component system. One component. This is a one component system PT graph. It is a phase diagram graph. Why it is called a PT graph? According to taken x axis, that is the temperature. According to y axis, pressure and atmosphere. Atmospheric pressure. Here I draw a line AB here. This is the AB. In this, the two solid polymorphic forms. Here, two solid polymorphic forms. Here, the arrangement of crystals. Here, the arrangement of atoms. The two solid polymorphic solids are formation here. I write here. Understood? SR means rhombic sulfur. Rhombic sulfur. Rhombic sulfur. This is a solid. This is a solid. And SM. Take a SM here. This SM. SM is monoclinic sulfur. Monoclinic sulfur. This is a solid. The arrangement is different. The different arrangement, the formation structure is here different because of two polymorphic solids are forming this sulfur. Okay, next. Yes, yeah. Liquid. Yes, L means liquid sulfur. Okay, next. SV. SV is a sulfur vapor. This is in liquid. Sulfur vapor. This is in vapor. Okay. Here SR is taken, SV is taken. SR means rhombic sulfur, SV means sulfur vapor or vapor sulfur. You say about sulfur vapor or liquid sulfur or sulfur liquid. Okay, here Sm means sulfur monoclinic. Here S means sulfur vapor. Okay, here Sr means rhombic sulfur and sulfur monoclinic sulfur. And here Sr is a rhombic sulfur, Sl is a sulfur liquid. And here Sl is a sulfur liquid and this Sv is a sulfur vapor. And this here this is a this curve Sm Sl because of fusion curve. Okay, here all the four phases here in this diagram, all the four phases can be represented by here only one chemical species. One chemical species, that is sulfur system, and therefore it is called as a one component system. And here this is a melt the two crystal compounds. One is a crystal compound, crystal solids. One is a rhombic solid, sulfur rhombic, and another is a monoclinic sulfur. These two are exhibiting this here the 95.6 degrees Celsius. The 94, the melting point of this exhibit a transition point. Here this is also another transition point of this. It is a transferring here Sr to Sm. At equilibrium state, it gets this is a 95.6 degrees Celsius. 95.6 degrees Celsius. When these two rhombic sulfur and monoclinic sulfur are in equilibrium, it says transition point is 95.6 degrees Celsius. When this below this point, the rhombic sulfur is stable. Above this point, the monoclinic sulfur is stable. You say this is the below the rhombic sulfur is stable. This is above this point, the monoclinic sulfur is stable. You remember this is a one condition. When both are in equilibrium, it gives the transition point, that is a 95.6 degree Celsius. In this, the phase diagram of sulfur system, some features I write here. Here this is a first one is the six curves. Here six curves. One is I write. You know this these are the okay, some features in this. For sulfur system consists first one curves, six curves. See AB curve and AB to DC curve, next CD curve, next here BE curve, AB curve. Next BE curve. Next CE curve. Next another EG curve. EG curve. There are 6 curves are there in the sulfur system. A, B, B, C, C, D, D, E, C, E, E. Next, areas. In this, 4 areas are present here. Second one, areas or regions. Areas 4. Okay. First area here, A, B, E, G. First area, A, B, E, G. This is a solid rhombic. Okay. Next, second one here, that is liquid. Second area, first area is a solid rhombic. Second area here, B, E, C. B, E, C. Here, solid monoclinic. This is a solid monoclinic. And another GECD. Here, this is a GECD. Liquid sulfur. Presence of only one phase here, liquid sulfur. Okay. Next, another A, B, C, A, B, C, D. This is the sulfur vapor. Sulfur vapor. How many curves are there? 6 curves. Areas is 4. Triple point. 3 triple point are present and 1 is a metastable triple point. This is a metastable triple point. Right here. Third one, triple point. Triple point B and C and 1 metastable triple point. Metastable triple point. That is here. Okay. These are the features of this sulfur system. In this, we consider this curves. First one is the AB curve. I am considering here this AB curve. Okay, this AB curve is represented as sublimation curve. It is a rhombic vapor pressure of rhombic sulfur. When this is vapor sulfur, that is here, when equilibrium is attained, here this transition, it is a transfer from here equilibrium state rhombic sulfur to sulfur vapor. Because of this is known as the sublimation curve. Here the curve AB is, that is a vapor pressure curve of SR. This SR means rhombic sulfur. Here it shows the vapor pressure of solid rhombic sulfur. This is a vapor pressure curve of solid rhombic sulfur. It is in a different temperature. Rhombic sulfur in a different temperatures, and along this curve, 2 phases. Along this curve, there is 2 phases are present here. The variation, that is here, 2 phases are present. One is a rhombic sulfur and another is a sulfur vapor. Yet in equilibrium, it attains equilibrium two phases are present here. That is, this is a mono. When two phases are present, it is a monovariant in nature. And here curve, I write here curve AB. This curve AB, that is f is equals to c minus p. C minus p plus 2. Here component is 1 minus phases are 2 plus 2. Here f is equals to 1. All curves are monovariant in nature. AB curve, BC curve, CD curve, CE curve, BE curve, AC curve. These all 6 curves are monovariant in nature. The system is a monovariant in nature. And next, I consider a BC curve. Here, I consider BC curve. Here, this BC curve is also called as sublimation curve. Here, it is the vapor pressure of monoclinic sulfur. This curve is the sublimation curve. This is vapor pressure of, it represents vapor pressure of monoclinic sulfur, and it shows the variation of vapor pressure. That is the vapor pressure of a monoclinic sulfur with the temperature and Sm here. Smi is where I already written that is Smi Sv. There are two phases attain at a equilibrium state, that is here Sm and Sv. Sm and Sv, here one is a monoclinic sulfur, another is a sulfur vapor. This is a monoclinic is solid, here rhombic sulfur is solid. Here vapor and vapor is present. And here two phases are present and plus 2, 1 minus 1 component system, and this is also a monovariant in nature. The system is a monovariant in nature. Next, I consider this CD curve. This CD curve. And here I consider CD curve. This is a vapor pressure curve of liquid sulfur. Vapor pressure curve of liquid sulfur, and it is a variation of vapor pressure, variation of pressure with temperature, and attain at a equilibrium state. Here two phases are there. One is a liquid sulfur, one is a sulfur vapor. And here two phases and one component system plus 2, you get a 1 minus 2. The F is equals to 1. Here this system is also in a monovariant in nature. Okay, next another curve. AB is complete, BC is complete, CD is complete. And next, second, BE curve. This BE curve. This BE curve is called as a transition curve. Because of here SM, it is transition takes place SR to S. SR to SM. Here it is a rapid heating, it is not converted here SM. It is a metastable, it comes in metastable, so I explained in that point. Here the transition curve, here the formation of transition, the different directions here, the formation of BE is a, here is one in, those are two phases are in solid, one is a rhombic sulfur, another is a monoclinic sulfur, and you get a transition point here to form. This is at equilibrium state. This transition point is formed, that is a 95.6. This is the transition temperature 95.6 degrees Celsius at in a equilibrium state. The rhombic sulfur and monoclinic sulfur are in a equilibrium state. Here because this is also, that is a monovariant. Here the system is monovariant in nature. Next is I take a CE curve. CE curve. This curve is known as a fusion curve. This is a fusion curve. It is a, this CE curve is known as a fusion curve of vapor pressure of, it represents vapor pressure of monoclinic sulfur, and here it is effect of pressure, and here the mean at the point this SM, and the phases are present here. One is the SM monoclinic sulfur and another is a SL liquid, that is the sulfur liquid. Similarly here the absorbing, here also two phases, one is the sulfur liquid, one is the monoclinic sulfur, one is solid, one is a liquid, and here F is equals to C minus P plus 2, the component is 1, it is also F is equals to 1, that is the system is monovalent in nature. Next another, this is the EG curve. Here EG curve, this is the easy curve. This curve is known as a fusion curve because of here the S curve. This is upper is a S curve. Here it is a variation of the effect of pressure. Here also effect of pressure. Pressure increases here. The effect of pressure. The different direction. One is the B curve and another is the C curve. And this is the different direction. It form a easy curve. Easy is here. At equilibrium state, this comes at equilibrium state. That equilibrium state comes two phases at equilibrium. One is the rhombic sulfur and another is a sulfur liquid. Here also this is easy is also, that is a monovariant in nature. The system is monovariant in nature. And the curves are completed. Next, second areas. Okay, here areas. How many areas? Four areas. A, B, E, G. You know already areas I discussed in one component system. That is a B, E, G is a only one phase here. That is a solid rhombic. Okay, and here you considering B, E, C. B, E, C. This system is a, this area is a monoclinic sulfur, and we consider GECD, this GEDC, GECD, this area consider that as a liquid sulfur or sulfur liquid, and this area ABCD, this area is, this region is considered as a sulfur vapor. Whole, and so here whole system, the presence of in area only single phase is present, that is the phases here areas are bivariant in nature. The system is a bivariant in nature in the areas. Okay, next, third one is a triple point. This triple point. Here the metastable state is come here. The triple point, there are three triple point. This is a continuation curve for this continuation curve. The B and C, this is a continuation curve for this E. Okay, this sulfur rhombic and sulfur monoclinic continuation curve, and this is a fusion curve, and this C curve is also fusion curve. It is melting takes place. The melting point of this one 114 degrees Celsius and melt. This is a rhombic sulfur. This is a here monoclinic sulfur, the melting point of monoclinic sulfur. This point get here monoclinic sulfur. You know the triple point BEC. The BEC, when triple point you comes your mind, triple point means all three phases are in a equilibrium. Three phases are in equilibrium. Here I consider triple point B. First one, triple point B. Triple point B. F is equals to C minus P plus 2. Okay, triple point, this is the, in triple point, meet at the point, three curves are meet at the point, this B point. Here one is A curve and A meet at the point B, C curve meet at the point B, and E point meet at the point B. And here SR, and this is SV, and this point is SF. Here this point gets the three phases in equilibrium. Three phases are in equilibrium. Here this point gets the SR, SM, SM. Here the three phases are in equilibrium. That point is known as the triple point. Here component is 1 minus phases are 3 phases plus 2. Here is equals to 0. Here the triple point is a non-variant in nature or invariant in nature or zero variant in nature. Here all three triple points are zero variant in nature. If the system is a zero variant in nature according to this triple point B. This triple point B and another triple point that is of C. Here another triple point C curve. Here C curve, the DC is here, the point D is, this curve is made at the point this and this curve made at the point this and this curve made at the point this. These are in equilibrium and here in equilibrium state the phases are 3. There are 3 phases. Here it is coming from this to this. One is a SM curve and this to this and this to this. Here SM, SL, 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 SL. These three phases are present in triple point C. One is a monoclinic sulfur, one is a liquid sulfur, and one is a vapor sulfur. And another point, this point, it is a continuation core of this chromic sulfur, and here this point presents 3 phases. What is here? The G is here comes the point, and B is comes here this point, and C is comes here this point. Okay, here one is the SR. Okay, this point coming to this point SR, and this point coming to this point here SL. Sorry, SR, SM, SM. Okay, not a vapor pressure, vapor curve. Here there are options of vapor. Here options of SR. Here options of SCM. These three phases are equilibrium state. This is a non-variant in nature or zero variant in nature. And this completes triple point. And next comes metastable state. Here SR, SL, SM. Here the next metastable state. Metastable state here, the metastable equilibrium is, it comes from here. You consider a curve. This is a continuation curve comes here, and this is a continuation curve comes from here, and this is a continuation form comes from here. This is a metastable state. When metastable state, the here the transformation of the transition of SR to SM, SR to SM. This transition is when heating takes place, it is impossible to convert. The interconversion is impossible in a given time. Here the rapidly heating, it is a high temperature is given. It is impossible to interconversion of SR to SM when it is impossible, and this SM is neglected here. Only 3 phases are present in the metastable state of sulfur. Here SR, SL and SV. Here SV. These 3 phases are present in a metastable state. It is comparable with water, and it is water metastable of this sulfur and water system is same here. In water system, the uh, 3 are curves, and one is a triple point and 3 areas. 3 areas, 3 curves, and one is a triple point. Here also same. Here 3 curves, 1, 2, 3. 3 curves and one is a triple point. Here this is a metastable equilibrium. Here consider 3 curves are present here. Here one is a BF curve and another is a CF curve and another is a EF curve. Okay, here BF, CF, EF. I consider curve here BF curve. BF curve. In this BF curve, the vapor pressure curve of the metastable rhombic sulfur. You know here the metastable rhombic sulfur, this curve is continuation takes place here. The transition of here curve. This is sublimation curve is transition takes place here. That is this continuation of the vapor pressure curve of a stable rhombic sulfur. This is a AB line. The rhombic sulfur AB line continuation. It is the metastable phases are SR and SV. Here metastable state is SR and SV, and continuous formation it is are in equilibrium along with it monovariant in nature. This is also monovariant in nature. Here because of here the SR and SV is a continuation curve of this metastable state. And similarly here the dashed curve CF. This CF, this is the continuation curve of vapor SL and SV. Here is completely it is a high pressure, high temperature, and SV is converted in this SR. Here it is you know already yesterday I told here I taken this piston and when it is temperature the two states liquid and solid and liquid are in equilibrium. The all solid not convert here complete not convert here in a liquid state. When completely converted the temperature is start increasing or rises the temperature here. Okay, the CF curve that is the vapor pressure curve. Here the vapor CF curve, vapor pressure curve of sulfur liquid, and here SL is a super cooling, the cooling of slowly cooling super cool of this CF curve, and it is a dashed CF line. This hence the curve is represents a metastable equilibrium state, that is a SL and another SV curve. Here the two phases are present. Here sulfur and sulfur vapor. That is a liquid sulfur and sulfur vapor. Next another this EF. This EF curve also it is a dashed line of this EF line here. This fusion curve here. This is known as EF curve. Here EF is a this continuation here. One is a SR and SL. One is a rhombic sulfur, another is a liquid sulfur. Here the two phases in a metastable state. The two phases are metastable state and formation that is a monovariant in nature. Here SR and SL is the EF curve. And next another this is F is a metastable triple point. Another F this F is a metastable triple point. This is comes from here, this line comes from here, this line comes from here. These three are SR, SV and SL. Here SR and here SL and SV. This is the SV, SL, SR. These three are in equilibrium in a metastable state. Here Df is equals to this F triple point is C minus P plus 2 is equals to one component system minus P is 3 phases plus 2 and plus 2 plus 1 3 minus 3 is equals to 0. Here F is equals to 0. Here SR, SL and SV are in equilibrium. The system is a metastable at equilibrium. The triple point is no degree of freedom. Here there is no degree freedom or it is a monovariant in nature or non-variant in nature, zero variant in nature. This is a explanation for a sulfur system. I given complete explanation for a sulfur system. Here, this is a transition temperature. This is a transition temperature. This is known as transition curve because transition curve is a transforming SR to SM, solid to solid. Okay, this is the explanation for sulfur system. Okay, I stop here only. I continue next class.